Let's go!
Hi and Assalamualaikum. My name is Fatina John binti Muhammad Salihin and my student ID is 2022841588.
My name is Putri Zulaikha binti Shukri. My student ID is 2022484444.
Hello, my name is Nur Shahira binti Nozamri and my student ID is 2022862362.
My name is Diana Batusha binti Zulkarnain. My student ID is 2022836148. For this project, our topic is the relationship between the total date of COVID-19 from public cluster and the total of COVID-19 per day. This mini project is meant to find the best fit curve for the total date of COVID-19 from public cluster. The following data from Ministry of Health of Malaysia shows that the data relationship between the number of date of COVID-19 per day. Hence, in this assignment, we'll use these three mathematical model, which is linear model, quadratic model, and cubic model. We indicate the total date of COVID-19 from public cluster is X and the total of COVID-19 per day is Y. The next table will show the data of our project.
Today, I would like to explain about relationship between the total death of COVID-19 from public cluster and total COVID-19 per day by using linear model. As we can see here, the equation for linear model is y equal to a plus bx. Therefore, from 21 data that we get, we can substitute the data into the equation by using total death of COVID-19 from public cluster as our x and total COVID-19 per day as our y. After that, we can set a matrix form, which is for matrix M is a matrix 21 by 2 and matrix Y is a matrix 21 by 1. After form a matrix M, we can find M transpose by transposing matrix M. After that, we need to multiply M transpose with matrix M as we can see in the formula given. After that, we need to multiply M transpose with Y to substitute it into the formula. To find V, we need to inverse matrix M transpose with M. After that, we can get the value of A and B. Hence, we can use the value to substitute it into the formula to get the best fit linear curve. Moreover, to get the error vector, we can substitute the value of y, m, and v into the formula given. After that, we can get the magnitude of error vector. This is the linear model maple output. This is the error vector graph for linear model. As we can see, there is the positive relationship between total death of COVID-19 from public cluster and total of COVID-19 per day. Since there is a detectable pattern in the residual plot, we can conclude that a linear model is not a right fit for the data.
I will continue my part with quadratic model. The equation for this model is y equals to a plus bx plus cs squared, and we will substitute all the 21 data into the quadratic equation. Then the total COVID-19 per day called as y and total date of COVID-19 per day is x. And also we need to square the x value to get x squared. We can represent the equation into the matrix form after substitute x and y value to get 21 by 3 matrix as matrix M and matrix Y is 21 by 1. Then we need to find M transpose and the matrix will be 3 by 21. Next, we find M transpose M by multiplying M transpose with matrix M, and we will get 3 by 3 matrix. After that, we will find M transpose Y by multiplying M transpose with matrix Y, and we will get 3 by 1 matrix. Next, to get the value of phi, to find best quadratic curve, we need to find inverse of M transpose M by using elementary row operations because it is 3 by 3 matrix. Then we multiply inverse of M transpose M with M transpose Y and get V with the dimension 3 by 1 matrix. After that, we will get the best fit quadratic curve by substitute the value into the formula. Next, we find error vector by substitute y, m and v using formula E equals to y minus mv, and we'll get as followed. Then to find the magnitude of error, we just square root the E and we will get the answer. Next, this is the quadratic model maple output for matrix A, M and Y. Next, this is the output for M transpose matrix, M transpose M matrix, M transpose Y matrix, and inverse of M transpose M matrix. Next is the output of V matrix and magnitude of error vector output. Then, this is the graph for error vector graph for quadratic model. As you can see, the graph is open upward, and since there is a detectable pattern in the residual plot, we conclude that a quadratic model is not a right fit for the data.
So today, I would like to continue my part to explain the cubic model. So the equation for the cubic model is y equals to a plus bx plus cx squared plus dx cubed. The data that we have is 21, and we substitute all the data into the linear equation where the total of that from public cluster is x and the total of COVID-19 is y. After we enter the value of x and y, then we can get the matrix representation form, which is matrix M is the dimension of 21 by 4 and y is 21 by 1. Next, the formula to find the least square solution is M transpose multiplied by M and V equals to M transpose multiplied by Y. The first step is we need to calculate the M transpose with the dimension of 4 by 21. Next, we find the M transpose M by multiply the M transpose with the M, and then we can get the MTM with the dimension of 4 by 4 matrix. And the next one is we need to find M transpose Y by multiply M transpose with Y value, then we can get MTY with the dimension 4 by 1. The next one is we need to find the inverse of M transpose M, and we can get a 4 by 4 matrix by inverse the matrix. As we substitute all the value into the formula, we can get the best fit curve. So to find the error vector, we can use formula y minus mv, and to calculate it, we need to find the mv first. And finally, we can get the magnitude of error vector. So this is the example of the cubic model maple output. As you guys can see, this is the graph of cubic model maple output. So the first one is the graph of error vector, and the second one is the graph of best fit curve. There is the detectable pattern in the residual plot in the first graph, so we conclude that a cubic model is not right fit for the data. So for the second graph, we can get the value of y.
Lastly, analysis and conclusion. We conclude that the best fit curve obtained in this study with the least minimum error is cubic model, and with the magnitude error 28.104664764684800 unit. The graph show is the cubic model. This is the best approximation because it has a minimum error in the term of each magnitude compared to the linear model and quadratic model.